All right, so we already talked about z-scores yesterday, so hopefully you have some level of familiarity with that. I will go ahead and share the answers real quick. It looks like most people thought, or half of you thought A, and then kind of a split between B and D otherwise. So there we go. Now there might be a best answer to this, but it looks like there's two correct answers. So without knowing anything else, we know that our z-score calculation is z equals x minus the mean divided by the standard deviation. So the standard deviation being in the denominator means this is inversely related to the z-score. And what that means, as our standard deviation goes down, the z-score is going to go up. It's going to go up in absolute value. So what that means is the best answer for this one will probably be it's further from the mean. That's probably the best answer. But it's also true in this case that it's going to go, well, actually, no, okay. I'm rereading my question a third time now. And that is the best answer because there is a possibility that your value will actually get bigger absolute value, which means bigger in a negative direction also. So it's going to move further from the mean. It could potentially increase in value. So that is correct, but it's also incorrect because if you already had a z-score that was negative 2.4, okay, then by changing your standard deviation, that's going to go up in absolute value to maybe negative 2.5. I'm making something up. So the absolute value will increase. It's going to move further from the mean. And I guess this is a thing in English that always confuses me, and I probably get it wrong every single time. Is there a correct time to use further versus farther? What do you guys think?
Interchangeable.
Okay. I always feel like there's a right one for a situation, and I feel like I choose the wrong one, but maybe they are completely interchangeable.
I didn't know that for sure. I just I choose to disregard English rules like that because, like,
I know lie and lay, you can't, if you are doing the action to yourself, you lie down. But if you put something else down, you lay it down. I think that's how that one works. I know this is turning into a English class right now. I just hate getting things wrong. All right, let's go ahead and sign in. So we are going to be learning a couple of important functions on your calculator today. And we're going to start with normal CDF. If you read the chapter and followed along with the examples, you already saw this, so it's just going to be a little bit more practice. So normal CDF, that's a weird name for this. And I'll tell you how to find this function in a minute. But normal means that it's related to a normal distribution. Sometimes you'll see normal capitalized. For about half the year, I capitalize normal, and the rest of the year I don't, but it's not that big of a deal. So we're going to see other types of CDF later. And for most of the year, it's going to be normal. CDF is a cumulative density function. And you're going to see an option for normal PDF, and we never use that one. That is, so bottom line, don't worry about normal PDF. And the percentiles are always measured from bottom up. That's going to be, so if you're looking at a distribution and you're trying to figure out where 25%, the 25th percentile is, they're going to live somewhere around right here. So 25% of the day, the 25th percentile means 25% falls below that point. It's not, the 25th percentile does not mean that point right there where 25% is above it. It's only, so it's not that one, it's this one. Okay, that's going to be important as we go through this today, because we're going to see a lot of stuff about percentiles. Okay, on your calculator to find normal CDF, and I'm not necessarily going to give visual demonstrations of this, but you hit second, and then you'll notice by the arrows you have vars, variables. So the second, and then that button brings up your distributions menu, and normal CDF is the second option. You can see normal PDF, we want to just skip right past that one. And you can go ahead and open up that menu because it's going to bring up another thing. You see lower, upper, mu, sigma, and paste. So lower option sets the lower bound of the area you're interested in. And this might not make sense right now. I'm going to kind of walk through it in more detail. The upper sets the upper bound. Okay, it's second, and then vars is the main button. It's just above your tangent button. All right. So if there's still questions, there was a question about that, so I'm just answering. Okay. So upper is going to set the upper bound of the area that you're going to find. And mean and standard deviation set the parameters for our model. And so we're actually talking about, this is taking a normal, and I have another slide that explains this, but I guess I'm kind of talking about it now. We're taking a normal curve, and we could set the mean and standard deviation to whatever we want. But we are going to leave it at 0 for the, 0 for the mean, and the standard deviation over to here is going to be 1. So we're going to leave it like that. We'll talk about it. But this function is essentially saying, hey, tell me what your lower bound is. Oh, your lower bound is right here. Okay, where's your upper bound? Oh, it's right here. So it's going to find the area under the curve right here. It's doing some calculus for us to figure out that exact area under the curve. And it saves us from having to do the calculus, so that's very nice. So this shortcut function saves us a lot of time. Okay, if there is no upper or lower bound for the problem that you're working with, just set them at plus or minus 99. So if it's an upper bound, set it at positive 99. If it's a negative, just set it at negative 99. It doesn't have to be a crazy number. So you can see, maybe you can tell in this menu option, they have like 9999999 just going on forever. Honestly, when we're talking about that many standard deviations, 99 standard deviations is huge. We saw that 99.7% of data falls within 3 standard deviations. So if I'm going all the way out to 99, that is just a crazy amount. All right. And if this doesn't completely make sense right now, we'll get some practice using it. So like I was saying, we're always going to use a mean of 0 and a standard deviation of 1, which means we're standardizing our scores. We're going to get z-scores every single time we do a problem. And there's a couple reasons for this. Do I say anything about it? Yeah, we standardize because later in the course, we're going to have to show our work. And the best way of doing this is to show how we calculated our z-scores. So a lot of times the calculator does a bunch of work for us, and we can't just put, oh, I put my numbers into a calculator and this is the answer. That doesn't count as work. So if we show our z-scores and how we calculated them, then that kind of works as our work. So that's one idea. The other is that some problems we're working, and we're going to see this toward the end of class, some of the times we're working backwards. We need to find the z-score first and then work backwards. So we need to be comfortable with using the z-score formula, which again, I'll just write up here. X minus mu divided by sigma. We want to have that just ingrained in our brains. Okay. So this is, I already kind of explained it, but now we're going to go through it again. When we set a lower and upper bounds, we are finding the area under the curve. Okay. So in turn, that's going to tell us the percent of cases that fall within those bounds. Okay. So this is something that will come into play. We're talking about the probability of a case being within a particular range. So it's worth mentioning that the entire area underneath the normal curve is 1. This total area is 1. So if I only get part of this area, like maybe say from here down to negative infinity, then this is going to be some fraction of 1. And let's say this is right at 20.28. So that means there is a 28% probability that my data point is going to fall in that range. And vice versa, 72% probability that it's going to fall on this other side. Okay, now I guess we could say more about it, but I think that gets the idea across. And like I said, we don't have to do the complex math. We just need to punch in a few numbers. All right, so now we're going to be doing some practice problems. I'm going to go through the first one and maybe the second one too, but then later I'm going to say like, okay, everyone do this and let me know what you get. So if we look at the first one, we're going to always want to have this z-score. In fact, I'm going to write it up in the top left, top right, because I want it to be there for every slide. All right, so we've got a normally distributed population. These are orders being filled in a workhouse, in a warehouse, workshop, warehouse, workhouse, workshop. There we go. And we've got a mean of 48 seconds to fill an order, standard deviation of 6, and both of these have the same unit. So if that is something that you kind of missed along the way, that's supposed to be a C right there. So standard deviation has the same unit as the mean and the data points. All right, how many orders will be filled in no more than 54 seconds? Now this one's pretty nice because if I plug these numbers in, 54 is the data point of interest. That's our X here. Minus the mean divided by 6 gives us 6 divided by 6, which is just 1. We have a z-score of 1 here. And we didn't talk about it a great deal yesterday, but there were some problems in your homework where you probably saw this, where with the 68, 95, 99.7 rule, the empirical rule, I know that 68% of the data is going to fall in the middle, which means there's going to be, of the remaining amount, which is 32, there's going to be about 16% that falls over here. I'm not worried about every single division, but 16% is going to fall right here. 16% is going to fall right here. 68% is in the middle. If I have a z-score of 1, then how many orders will be filled in no more than 54 seconds? So now we're saying basically what percent of the orders fall in this range right here? And I don't even need to use my normal CDF function for this. All I need to do is say, well, I know 16% is above that. So that means it's going to be 1 minus 0.16, which is 0.84. So we're going to get about 84% of the data fall below that point. So I'm going to pause there. Are there any questions? Did that make sense to everyone? All right. If you don't like thinking through the problem that way, we could have put this into our normal CDF function, but we're going to do that with our next one. All right, so if you came back to this and you're like, I don't want to do that kind of thinking, just let me plug it in the calculator. You can do that. All right, so I think I'm going to have to rewrite this z-score function every time anyway, because it's faster that way. This looks like the same problem, except we changed our standard deviation. Now we're not going to end up with this nice z-score of 1. We're going to get some kind of a decimal. All right, and I'll just do that real quick. So it's going to be 54 seconds. That didn't change. Minus the mean still hasn't changed. It's 48 seconds. But now I'm dividing by 5. So that gets me 6 divided by 5. I have a z-score now of 1.2. And there's no way of doing a quick, thought experiment to figure out what this is. What our percentile is. So before I do anything else, I want to say this. Essentially, I've got a z-score of 1.2. And you can see the 1 down at the bottom. So this is my z-score of 1.2. How many orders will be filled in no more than 54 seconds? So I'm trying to figure out what's the area under the curve from that upper bound down to negative infinity. So on your calculator, I'll direct you back to your normal CDF. So just as a reminder, you hit second and variables, you go to your distributions menu, select normal CDF, and you've got your lower bound is probably right now, unless you got a calculator and someone still had work left over from last semester, it probably just says negative 1e to the 99th power. So that's basically saying negative infinity. That's your lower bound by default. And luckily in this case, we can keep it there. Negative infinity or negative really big number, that works for us. The upper bound, well, we can see right here on the graph. That's why I'm actually drawing this. It's going to negative infinity, but I'm going only up to 1.2. So I want to put my upper bound as 1.2. And because it's a z-score, I keep the 0 and the 1 the same. And we can see the answer here. And if everyone is able to do that, it's 0.8849. Hopefully everyone got that.
Can you go through that one more time?
Yeah, is for the calculator buttons you need to do?
For the calculator.
My calculator, when I like click on it, it doesn't like show all the different options like for like the minimum and all that. It just like tries to
Does it just open up normal CDF with an open parentheses?
Yeah.
Are you on a TI 83?
It's a TI 84.
Is it one from the school?
No, it's not.
Okay. I mean, what you need is a firmware update. Okay, and so you have two options. I can try and tell you how to do that. I can talk with you separately. Or you can go to the school and pick up one of these. But yeah, basically it's a free thing, but you'll need to kind of go online and download the new firmware so that you have the interface. So in the meantime, I can tell you you're going to plug it in. So normal CDF, open parentheses, this is what you're looking at. You're going to start with your lower bound, then your upper bound, then you're going to have your mean and your mean and your standard deviation. So for this problem right here, your lower bound would be negative 99. Your upper bound is going to be 1.2, and this is going to be 0 and 1. So if you plug that in for the parentheses, then you will get the same answer.
I have that, but it says 0.7831.
Maybe I put it in wrong. Upper is 1.2. Did I? 0 and 1. I don't see anything. Did everyone? Well, let's kind of figure this out. Did you guys get 0.8849?
Yeah, I got that.
Okay. So I'll walk through it one more time. And so I hit second and the variables button.
Well, my answer changed to 0.88.
Oh, okay. Yeah, that can happen. And so it's a good idea to go through this twice, especially at the beginning, but it'll get to be second nature. So once you go to the distributions menu, just right at the very first thing, the second option is normal CDF. I set my lower and upper bound. It's good to have a drawing for this so you can visually see where your lower and upper bound is. My lower bound is negative infinity. And if you don't have anything there, you can just put negative 99. That's good enough. Your upper bound is going to be the z-score we calculated, 1.2. 0 and 1 for your mean and standard deviation stays constant. We never change that. And once you paste it to your screen, you can just run that analysis again, and it'll tell you. Okay. Let's move ahead. We're going to do more of these. So if it's not completely clicking, and Matt, hopefully with this right here, you can just keep doing the normal CDF and just remember that it's the same order. Lower bound, upper bound, then 0, 1 for your mean and standard deviation. Okay. So we can see we're going to keep working with the same basic scenario, but we're going to change things a little bit. So everything's the same, but now the CEO says that if you take more than 1 minute to fill an order, you will have a mark against you in your file. How likely is it that this will happen on any given order? We're going to assume that every order is equally random, and anyways, what I want to do is I want to kind of draw a picture of this, and I'm going to start by calculating a z-score. So my z-score is going to be 1 minute. This is the value of interest here. So of course that's 60 seconds. So 60 seconds minus the mean of 48 divided by 5 is going to be 12 divided by 5. And that's going to be 2.4. So that's my z-score. And the reason I have this normal curve that's drawn here all the time is so now I can actually plot that point. So -2, I'm going to come up to -2.4. It's about right there. Sorry, I said -2.4. I don't know if I said that, but 2.4. So if you take more than 1 minute to fill an order, you'll have a mark against you in your file. So what I want to figure out is what is the probability, essentially we can think of it that way. What is the probability of getting that 2.4 or higher? So, because I don't care if I'm less than a minute, I care about getting 1 minute or more. So I want to get this area right here. And this technically just stretches on infinitely far. So when I look at that, I can see it's going to be a normal CDF calculation. I want to get the area under the curve. So I'm going to do second and distributions, normal CDF. But now my lower bound is going to be that z-score, 2.4. And my upper bound will be positive infinity. That's where I'll put a 99 in. Keep the mean and the standard deviation the same. And I will let someone else write that in. What is the probability of getting a z-score of 2.4 or higher? All right. There it is.
I got 0.008.
There it is, 0.008, 0.0082. If we go to 4 decimals of precision here, very good.
How many decimal points should you go to on average?
You know, I think 4 on average is pretty good. Though there are going to be times where I tend to stick to 3 or 4. And I'd like to say that there's like an AP standard. You need to go to 3, but just make sure it's precise enough. I think one of the rules that you learned in your science classes is that you want to have the same number of significant digits as you have in your problem, but it doesn't quite work that way here. So 4 is a good place always to go. All right, that's a good question. All right, let me see this next one. All right, I'm not going to run through this one. I want to see if you guys can read through it and figure out what to do for this and what your probability of this will be. Resume. So I got that answer. I'm going to, now some of this is notation you don't need to know yet, but I guess I'm just going to kind of throw it out there. I'm going to move your answer real quick. Did get it right. Good job. But I'm going to put 0.055 right here. You could have done 0.0548 if you went to 4 decimal places. So anyways, this is the probability that our z-score is less than or equal to -1.6. So everyone should have got that z-score of -1.6. Hopefully that was good. And that means that we're setting our upper bound at negative 1.6. And our lower bound is going to be negative 99. And we're getting that area. Okay. If we're good with this, and again, if you're not good with any of this, just kind of put a star or flag something, make a note to yourself, and we can come back and look through the stuff at the end of class. Okay, so now here's this one. Again, I'm going to let you guys try and figure it out. I will just put on here the probability of, I'm just going to leave this blank, and you can put your answer in the corner when you're ready. So the idea with this is that we want to find two z-scores, the z-score for 50 seconds and the z-score for 40 seconds. We already did 40 seconds in our last problem. That's negative 1.6. I'm not going to run through the calculation. And then 50 minus the mean divided by the standard deviation, that's 48, and that should be 5. That's going to give us 0.4. So we're basically trying to figure out what is the probability that our z-score is greater than or equal to negative 1.6, but less than or equal to 0.4. So that's going to put it, my upper bound right about here, my lower bound about right here. We want to get this area, and by giving our calculator both bounds, it's going to find that area for us, right at 60% basically. Okay, looks like you guys are getting the hang of it. I don't see any questions being asked right now. All right, I will probably run through this one with you guys because this is a confusing problem, and I can give you a heads up, there might be a question like this on your test. So we are kind of combining last unit with this unit in a sense. So a bonus is given every month for every worker in the top 20% for fastest average shipping time. You know that one coworker is in the 13th percentile, one is at the first quartile, and you have a z-score of negative 0.9. Rank the workers in order from fastest to slowest and who qualifies for the bonus. So the first thing is just to keep in mind, in this case, do you think a lower or a higher z-score is a better thing to shoot for?
Higher.
All right. So we're looking at the time that it takes for you to fill an order. So in this case, a higher z-score means that you take longer than average.
Oh, I thought it was talking about like the other graph where you could fill more orders with a higher z-score.
I gotcha. That okay, and I do get that. That actually makes sense. So they tracked it by the amount of orders you filled, then and you're in the top 20%, then yeah, higher z-score. Here it's the average time it takes to get the package ready. So we want the lower the better, which is essentially two ways of saying the same thing. So we got 3 workers, and one of them's in the 13th percentile. I already know where they are. All right, so if I've got this normal distribution, the top 20%, I'm just gonna guess, is about right here. So that's the top 20%. Here's the cutoff. The 13th percentile means 13% of the data falls below them. They're already in the top 20%. And I'm just gonna guess, here's A. That's probably too low as far as where it should go, but it works for our purposes. One is at the first quartile. What is the first quartile? What percentile rank is that?
25%.
25.
20. There you go. So this is 20% right here, the 20th percentile. They're going to be up above that somewhere. So this is worker B. Now we've got a z-score of negative 0.9. So what I want to do is I want to just do a CDF calculation, normal CDF, to figure out what percentile rank is that. So if I made my lower bound negative 99, my upper bound negative 0.9, and hopefully you're following along at home, then that puts me, since I'm worker C here, at what percentile?
$18.4.
Perfect. So the probability of having a z-score of less than or equal to negative 0.9 is going to be 0.184. And we could go one step further if we cared to. So I'm going to just draw a line right here. That's going to be me, worker C. So in order from fastest to slowest, it's going to go A, then C, then B. And who qualifies for the bonus? We do, A and C. All right, so it's kind of, when I say it combines a little bit of last unit, it's because we're going to throw in this quartile. It's important to remember that this is a percentile rank, it's the 25th percentile. Okay. So hope if, like I keep saying, if you want to come back to this one because something didn't click, we can come back to it. But I will assume no questions unless someone speaks up quickly. Okay, now we're going to change the situation just a little bit. Now we're talking about our commute to this wear shop. All right, with a mean of 20 minutes and a standard deviation of 7 minutes, how likely are you to be late given that you leave at 7:30 for a shift that begins at 8? And of course, for this problem, we're going to simplify it. We're going to assume that just getting there is on time. We're not going to worry about what it takes to walk inside and get ready. So I'm going to let you guys try that one on. All right, so we have our answer already. And now we have a different scenario. So if I go back to this standard equation, now I'm not using the same parameters anymore. I've got new parameters to work with. So we can see that 30 minutes to arrive is kind of the specific value in this problem that we're focused on. It normally takes me 20 minutes to get there. I've got a 20-minute or a 30-minute window to get there. It normally takes me 20 minutes, but it's not always the same with red lights and other traffic. It can fluctuate. So what is the z-score of this? Well, it can be 10 divided by 7, which is about 1.429. However precise you want to go with that. Actually, just a general comment, and I'll probably say this a few times, but it's best to keep tons of precision the entire way through. And you've probably learned this from other classes. So the actual number here is 1.4285714 and so on. Keep a lot of precision as you're going through your calculations, and then just round for the very last step. So anyways, that's just a general comment. So now the probability of having a z-score that's greater than or equal to 1.43 essentially is 0.077. Now, even with a problem like this, it's good to have a diagram. That's gonna be one of the key things we can use to show our thinking. So my mean is, in this case, I'm not gonna put it in standardized form. My mean is 20, here's 27. So I'm just gonna put, a line right here to represent, this is 30 minutes. So a 30-minute commute time, what's the probability of being in this area where it's 30 minutes or longer? All right, we're just communicating our thinking visually here. All right, enough said about that one, I think. So but just a general comment, the more you get into the habit of drawing every single time, that's going to be an expectation as we get further into the class. And so develop those good habits now by just a quick sketch of a normal curve, where your z-scores fall and what area you're trying to find.
Hey, quick question.
Yeah.
How would you input the data into your calculator? Because every time I do it, I get like 0.99 or 0.91 or something like that.
Oh, okay. Okay. So for this one,
I could put it in the upper bound or in the lower bound.
yeah, you need to double check your upper and lower. So it just, with the drawing I just did, that's one possibility. Like we ended up with our 30-minute being about right here. So I want to make sure that the z-score that we got, the 1.43, is my lower bound. And my upper bound is going to be like 99, positive 99. So that could be the problem. If you went from negative 99 up to 1.43, you're going to get the inverse. You're going to get about 0.93 or something, 992.
So I have my data as the bottom one is the 1.4285714, and then the upper is 99, and then the mean is 20, and then the standard deviation is 7, and I still get 90.
Okay, that's it. Your mean and standard deviation are always 0 and 1 and that's a good thing. I'm glad that is happening now because we are standardizing. Every time we create a z-score, we are keeping it, we're standardizing our data to a mean of 0 and a standard deviation of 1.
Okay, thank you.
Yeah. So, yeah, it's actually a good thing that mistake happened. So you can just put in the actual numbers into your calculator and change the mean and the standard deviation, but that's not what we want to do in this class. I expect you to do your z-score calculation and do the 0, 1. Okay, and just a quick thing. So one of the students has a Casio. I think the Casio assumes that you're working with a standardized normal model. So you'll just plug in the z-scores and you're good to go. Okay, and I think this is the last normal CDF problem that we're going to do, and we're going to try and get through inverse norm today as well. That gives us less to do on Tuesday. So look at this one, see if you can work through it, and we will reconvene in a few minutes. Okay, very good. Now, the reason this question is here, it's just more practice, and it's good to just drill this home, this concept. But also, this is one that's based on an AP style question. So if you are thinking like trying to figure out how you'd be tested on this, it's pretty straightforward. You can see they give you a problem, you do the math, and notice, of course, you're almost always going to find the complement to that as one of your answer choices, because some people will go in the wrong direction, put their z-score as the lower bound when it should have been the upper bound. So that's kind of a clue you can use also. If you see two complements, of course, I would just suggest getting the right answer to begin with, but that'll help to reinforce the idea. Okay. Very good. Now we're going to be looking at inverse norm. This is kind of it's the inverse of the function we just were using. So inverse, it's the inverse of the normal cumulative density function. So if normal CDF allows us to find the area under the normal curve, then inverse norm allows us to find what z-score will give us that area. All right, so just to say it a different way, in normal CDF, we know the z-score, what's the area? In inverse norm, we know the area, what's the z-score? And this is where we might have some differences with people with their calculators, depending on what you're using at home. All right. And just a reminder that your percentiles are measured from the bottom up. So to find it, you actually already know how to find it. You go back to your distributions menu. And now it's the third option, inverse norm. And we are asking for the percentile. And sometimes the percentile isn't explicitly given. We kind of need to think through it a little bit. But there's always going to be some kind of a percentile we can use. And we'll see what different types of questions there are. Then the mean and the standard deviation. But again, these are going to stay 0 and 1. And this is where maybe it's good to find out right now. If anyone has the TI Nspire, then you have another option that says tail, which is left, right, and center, I believe. Does anyone have a TI Nspire at home and that's what they're using?
Mine's a TI-84 plus CE, but it still has the tail option.
Okay, it has the tail option. I know the school issued calculators don't have that. I'll kind of explain the differences there. You might, if you have the tail option, you might feel comfortable just keeping it as the left tail, but I'll explain how you can use your other tails later.
I think the default is right.
The default should be, what's that?
I was just gonna say I have a TI-84 plus the color one Kevin has, and my default is at left.
I'll tell you, every one of us with the yellow school calculator, we're gonna have a left tail. And I'll explain what that means in a second. So for the first problem, it won't matter, but you'll want to kind of keep it at left tail. I think it will remember the last tail that was used. So if someone else used that calculator, the last one they ever did was a right tail. Okay, and of course, these two parameters will stay at 0 and 1. Never, ever, ever change those. Okay, when we finish with this calculation, it's going to give us the z-score. So that will make sense here. So I'll run through this first one and a few of them, I guess. The salaries of workers at a large company are approximately normally distributed with a mean of 42,500 and a standard deviation of 2,700. If Theo is in the 75th percentile, what's his salary? All right, so we got our same formula. This doesn't change just because we're using a different function on the calculator. We're still using this idea. And here's one thing to keep in mind. With all of the previous problems, we knew everything on the right side. This is going to be kind of your litmus test or your sort of your clue as to which one of these functions you're supposed to use. If you know every piece of information on the right side, you're using normal CDF. And I'll come back to this idea. You don't have to have that memorized. So before we had something like 54 seconds minus 48 for the standard deviation, or for the mean, divided by 5 for the standard deviation. We knew all three of those. But now with this problem, if I plug this in, I've got z equals, I know the mean is 42,500. I know the standard deviation is 2,700. But I don't know the X value, what his salary is. I'm missing a piece of information on the right side. So this is going to be my clue right off the bat that this is going to be an inverse norm calculation. And where inverse norm comes in is right at the beginning, because they tell me that his salary is in the 75th percentile. Well, what z-score is that? I know that it's 75th percentile might be somewhere around here, but what is that z-score? I don't know. But 75th percentile, the left tail means that we're looking for all the data values below this point. And of course, it's going off to the left. So that's why it's the left tail. This is default for all of our calculators that are yellow. So you don't have to worry about that. So here's what I want to do. I want to go to my inverse norm calculation. So that's distributions menu, inverse norm. And the area that I'm looking for is 0.75. And of course, we know that the mean is 0 and the standard deviation is 1. And make sure you put in 0.75 as your area. And when I do this, my inverse norm is going to tell me this is 0.6745. Okay. And now I know that it's not this unknown z-score anymore. The calculator told me it's 0.6745. So at this point, I can actually plug that into my equation that I set up. I'm done with the calculator except to do the multiplication and stuff, but I don't need to do any other fancy functions with this. Now I'm going to substitute that in. 0.6745 is the z-score. X minus 42,500. And then 2,700 right here. And now it's just an algebraic equation. You know, we can solve that. I'm not going to go through all the steps of that. But I got that for his salary. All right. And if you didn't, you know, we can troubleshoot and figure out where you went wrong. So I'll pause just for a second if there are any questions. I see a thumbs up, so that's good. All right. All right, looks like everyone followed along with this. So let's look at another example. We've got a normal distribution of mature ponderosa pine heights. There's a standard deviation of 12 feet. If 30% of ponderosa pines are taller than 100 feet, what is the mean of the distribution? So I will need to use the z-score, but before I do that, I want to set up my diagram. So it's going to be this normal curve. It says 30% of ponderosa pines are taller than 100 feet. So I don't know where that is. 30% are above this point. I'm just going to put this randomly here and say, let's say this is 100 feet. And this represents, I don't know what the z-score is for this. But when it says 30% are taller, we're talking about a more extreme positive z-score. So this is the 30%. And at this point, this becomes a right tail. So the problem here is that our calculators can only do left tails. So what would my left tail percentage be?
70%.
There you go. So I'll just make sure that's very clear. 30% to the right, that means 70%, we're in the 70th percentile at 100 feet. Okay, now I'll just kind of walk through this and then I'll explain what you can do on your calculators with the right tail, which you could probably figure out. But for inverse norm, now actually before I do that, let me set up the rest of this. The z-score is unknown. I know that the x value of interest is 100 feet. So this is not the mean, it's asking me to find the mean. So 100 minus the mean equal or divided by 12 feet is going to equal this z right here. So I want to solve for z. And so I'm going to do inverse norm. And what it's going to look like is I'm going to have a 0.7 tail area with a 0 and 1 parameter. So if I write it out this way, area is going to be 0.7. The mean is going to be 0. Standard deviation is going to be 1. Now I can do this calculation to figure out what that z-score is. All right, and you guys can do that real quick. If you have the right tail option, you could also say 30% right tail, so 0.3 with a right tail. But if it's easier for you, just always convert it to a left tail and do the 0.7 with a left tail. You'll find you get the same answer either way. Don't worry about the center right now. That's not going to matter. All right, does that match up with what everyone else got? 0.5244? All right. Let's hope so. So now we can solve an algebra problem. So I told you at the beginning of the year, a lot of the math that we're doing is actually pretty simple. And so it's not so much math heavy and the complications there, if that made sense. All right, was everyone able to get that same basic answer? Okay, thumbs up, good. So, I mean, it's worth it just to talk about it for a split second to say that when you hear that someone's in the 70th percentile and you think, oh, wow, that means you're just way above, you know, it seems like, oh, that's pretty far above where most people are. But notice the difference between the 70th percentile and the mean is only just over 6 feet. And we're talking about a tree that's, I made these numbers up, but it seems realistic. So 70th percentile is at 94 feet compared to, or sorry, is 100 feet versus 94 for the mean. It just goes to show how close things are clustered around the mean. All right. I don't know how much more we have with this. Let me see. We got some more practice here. Let me read this one real quick. I'm going to skip this one. This is kind of more the same. Okay, let's do this one though. And we can kind of, if it helps you, if you already know what to do for this problem, just jump in and do it. But if it helps you, maybe we can talk first about what are we going to need to do? Just what are some thoughts to get started on this problem? So first of all, I'll ask this. If we're finding the IQR, what percentiles matter to us?
25% and 75%.
There you go. I have a feeling most people are just sitting at home working on this, so I won't bug you. If you feel like you know what you're doing, I'm just going to pause now. I'll be quiet. See if you can come up with the rest of the answer. So we've got the answer, and this is one of those types of problems. I bet everyone here had some percent of this you were doing correctly, but it's almost a lot of organization required in order to solve this problem. Like, wait a second, why am I solving this? And where does this go when I'm done with it? You know, there's a lot of stuff to keep in mind. So I want to first of all figure out, I'm going to start with this idea. The IQR is Q3 minus Q1. So as soon as I have those two numbers, I'm good to go. I just need to figure out what Q3 is. And Q3 is going to be whatever value lives right there. Q1 is going to be whatever value lives right there. That's Q3, and this is Q1. Now I need to figure out what those values are based on this model. So my z-score right here, I need to do an inverse norm calculation. It's going to be inverse norm. Knowing that Q3 represents the 75th percentile, I want to do 0.75 for the area with 0 and 1, which gives me 0.6745 when I round it. And we already did that one. What you're going to find is whenever we get the 25th percentile, it's just going to be the same thing and negative. So hopefully everyone was good with doing the inverse norm and getting those numbers. So I'm just going to go ahead and write that down, 0.6745. And this is going to be negative 6745. Okay. So that's all well and good. Now we need to go to the z-score. I want to find the z-score calculation. This is going to be for the Q1. And this is going to be for Q3. So I'm going to kind of do two different z-score calculations. X minus mu divided by standard deviation. And actually, I should do X of Q1 and X of Q3 minus mu by the standard deviation. Okay, so if I wrote this again, I now know the z-score for Q1 is negative 0.6745. The X value for Q1 is what I don't know, and that's what I'm solving for, minus the mean, which is 825, and divided by the standard deviation, which is 175. All right, now I'm going to do the same thing for so for Q3, the z-score is 0.6745. The x value is what I'm searching for, and 825 again for the mean, 175 for the standard deviation. I'm not going to do all the math except to say that in the end, your x of Q1 is going to be, did I do this right? Is 706.964. So when I solve this problem, that's what I get for my answer. X for Q3 is going to be 943.036 seconds. That's not a 5 at the end, that's S for seconds. Okay, so these two calculations give me those two answers down below. All right. Now I just need to subtract them. 943 minus 707 basically gives me 236. Okay, that is quite a bit of thinking to get through that one. And so here's what I'm going to do to make your life a little easier. I'll tell you, last semester when I did this, I tried to do it on Wednesday. We only got through half of it. And so we continued this on the Thursday. We did everything in one day, which means Tuesday we should have less to do. So you're sticking with me on this Friday, which means your Tuesday should be less time spent. All right. Now, if we look at this one, this is the last thing we're going to do, and then I'm going to give you your homework. And this one you don't need to spend too much time on, I hope. So there was a little bit of confusion, maybe just internal debate on which one of these, A or D, it should be. And luckily, you guys weren't tricked by this one. So we're going to have to convert to a z-score, and you guys all did that. The question is, are we looking for this z-score right here? Or are we looking for this z-score right here? So z-score 1 or 2? Which one is appropriate for this problem? Maybe another way of saying this, are we looking for the 40th percentile or the 60th percentile?
The 60th.
It's the 60th, because we want to have 40% of the homes above that point, which means 60% will be below it. It's the 60th percentile. So when you do that, it will actually be A. But the way this question is phrased, you have to kind of think through that a little bit. And your first intuition is going to, for some people, it's just going to be plug in that 40th percentile, 0.4 for the area and call it good. But it's 0.6 is what we're actually looking for. So there it is. Good work. And the fact that no one was saying B or C is already a good place to be at. All right, there are some other problems. If you want to get more practice, I encourage you to do that. Here's just kind of a wrap up to say, if you know the percentile, use inverse norm to get your X value or whatever you're missing, that is. If you know the X value and all the other information on the right side, use that to find the percentile. And just the best way of thinking about it, I already said it. If you know all of this, it's normal CDF. If you don't know anything, if anything up here is missing on the right side, then it's inverse norm. Okay. I'm so tired of talking, and you guys are tired of doing some statistics, I imagine. So there's your homework. It is not currently available, but I'm about to hit the button so you guys can do the homework. have a wonderful weekend. If you have any questions, stick around. And otherwise, I will see you on Tuesday.